draw some conclusions about these discussion and presentation of various topics. And actually, we have been discussing on very many items, so it's very hard that we can expect to have a resume of everything. On the other hand, we decided to not to go through the story again, because actually it's just an orientation of figures which are not that much important, or they are important, but they would deserve a much more analytic approach to be understood, so despite statistically relevant, because almost 500 teachers and 200 students is already quite a good statistical sample. But there is, in my opinion, one answer which is common to both categories, and they wrote, and probably most of them, not because they were participating just in the survey, because I convinced that both groups have a great expectation of the future of the field of statistical physics, not only for its own development, but also for future and disciplinary perspectives. And partly this is a feeling which is quite widespread so in the community. So you cannot just hope that since it is widespread, probably it will occur for sure, but there are good chances that some efforts, some great efforts made in some direction could really help succeed in such task. Not necessarily in the immediate or near future, but maybe also in a longer perspective. On the other hand, many other items raised, for instance, we are discussing just now, recalling with Paolo that yesterday and in other talks we are debating the idea of introducing from the very beginning concepts or presentations related to models forward from non-equilibrium approach, kinetic models and so on, rather than going through the whole machinery of equilibrium and then pass to non-equilibrium statistical. This is actually quite a first point that we can start from, and apparently it seems to me still debated inside this community, a small community, and probably it's a debate which reflects a great debate which is all over the community. And probably the answer is neither unique, because probably it depends very much if we are concerned with teaching these topics to physicists or to other kinds of students. And in my opinion, I mean, probably many of us share common opinions, but not all of us the same opinions. At least we have not still introduced the tax payment method in such a way that all we have the same kind of view on the problem. So I think that this would be, if you agree, a starting point, and probably many other points will come out of the beginning of the discussion.
Yes, we can start with precise. Finally, I have developed I don't say very precise opinion, but I think that if we teach to physics students, there is not really motivation to introduce non-equilibrium statistical physics before equilibrium statistical physics, because anyway these students will start equilibrium statistical physics. Perhaps we might think to give a stronger accent to dynamics when we teach equilibrium statistical physics. Instead, when we teach to non-physicists, perhaps also non-mathematicians, in that case, I mean, things are for me completely open.
You have experience of advanced courses in statistical mechanics in students who are not maybe apart mathematicians, engineering or computer science, biology. There is
okay, if you want, the question is slightly different. I mean, okay, to students who are not physicists, neither mathematicians, and you have to teach them a part of statistical physics. How do you do that?
People
But, you know, there are a number of texts devoted to biological physics that actually introduce very strongly the basic notions of random walks, diffusion, and so forth. And these are very useful. The books are actually extremely nice, and the approach is very restricted to a particular class of problem. And listening to the talks here, it was one of the points I was thinking about. If you think of statistical mechanics, non-equilibrium system mechanics as a subject taught to physicists, or even in fact to chemists, because we have the same program, then you have a core curriculum that you want to teach. When you look at the applications that we've talked about here, I can't imagine a single book actually covering these topics, because you know when you get into the details of a particular subject, they become very specific.
I don't know the detail, but there exists a booklet about random motion for biology.
Yes, in fact, I was trying to think of, there's Berg, of course.
Berg.
But there are actually some others by Nelson that are
I think it's random walks in
Random walks in biology.
It's a thin
Yeah.
book,
Yeah.
green, paperback. Howard Berg.
Yeah, Howard Berg. Yeah.
Yeah.
But there are even some other books that go into much more detail. on
I
molecular
agree, but I
machines.
think it was not
Yeah.
My experience is, I haven't taught biologists, but we tried to submit a paper to a more biological journal. And it had to do with nuclear pore complexes and, you know, going through these pores, and we tried to model it with TACEP and things like that. The reaction we got, that they don't understand the notion of discretization, you know, that you work in discrete space rather than, that's a problem. They said, well, the challenge that it's not discrete, it's not, you know, it's not atomistic, you cannot just hop from side to side, it's not a side. So I think if one teaches biologists, one has to try to explain this in a very clear way, you know, that this abstract thing and that the kind of things that you draw from it eventually applies to real space and whatever.
So there are actually a couple of nice books on this, written really for biological physicists.
Okay.
And that's the trouble, I don't think the biologists read them.
Coming back to Paolo's question, equilibrium first or non-equilibrium, let's focus just on biologists. I think perhaps, you know, there are two fields of biology we're addressing. There is all molecular and cell biology. And I think for those, it's extremely crucial that we teach them or that they know about equilibrium. And then there is this kind of biology, cancer, evolution, where this notion of temperature doesn't make any, or is not immediately relevant. And for those, perhaps you might want to start with non-equilibrium models. But I would be strongly against the idea that if we look at biology in general, that we could start with non-equilibrium. Because for all cellular biology, for all molecular motors, for what you just described, the notion of temperature is crucial. There is a heat bath. It's non-equilibrium, but it's on this background of the water molecules are always equilibrated. And this is something they have to understand. And that was also the point I was trying to make during my talk. And this is a completely different sort of biology than, for instance, the things Joachim talked about, or Eitan.
And there's another aspect to that we haven't touched on here. There's an entire field of biology that's devoted to basically the dynamics of proteins and their simulation and channel, and all of this is done at a molecular level, using typically molecular dynamics or Monte Carlo, but often the action, say, of the channel is really an out of equilibrium case, and this aspect is not totally treated. So again, this argues for keeping certain aspects of equilibrium processes in hand. Because we really start from that basis. I mean, ultimately, these are machines that are working at a molecular level and they're driven out of equilibrium.
And agree because on your last comment, because for instance, it's clear that people working at research level, mainly the problem, protein folding and protein folding, which is the molecule inside the solvent and so on, are very well trained in certain concepts of statistical mechanics, and in particular, those who are more successful presently use PERM, pre-enriched Clausen-Brut method, or go with the research, go with the strategies which are typical of statistical, advanced statistical physics, because they're applied also to solve problems that appear in kinetic models of a certain, level of complexity and so on. But I have the feeling that this is something very well known by a specific group of people that make research, and they train some kind of students at postdoctoral level to know the basics of these things. But to my knowledge, maybe I'm wrong, to our experience here in Italy, don't find any place that these topics are taught to chemists or people that will be involved in this kind of activity at, how to say, master thesis level.
I think that's not true in North America. I think it's a fairly big industry.
Already at master level, you find courses which are devoted to that. So this probably consequence also is a local problem because of the rigidity of certain kind of curricula which are imposed. So there is no real, how to say, degree of freedom to introduce courses. For instance, a course like the one Joachim was showing to us, which is going on actually in Köln now, and thanks to you and your colleagues, I think that in Italy would be practically possible.
Only, no, maybe a few, but
Where?
no,
Nowhere.
No. Actually, there is no.
Okay, it could be done, I agree with you, but
No, I don't know if this is possible in a biological department. No, probably not possible.
very difficult, much more difficult than physical. So on the other hand, it's important to know also that there are
No, because
cultural differences.
for example, in Rome, in my department, in the last time there was a certain effort to increase the field of I forget the sorry, le sequenze. No,
Genome, proteins, proteomics,
sorry,
genomics,
okay. When I remember it. Bioinformatics. So it's a certain effort in the direction of bioinformatics, because bioinformatics uses a certain technique of stochastic process, information transfer and so on, and is considered a promising field that can be useful to have some position for students. But this is the unique effort that's been done in the direction of biology. Specific topics, which is actually interesting, but not very general.
Of course, what is often taught in biology departments are courses where people learn to use certain program packages to analyze data. The problem is that often they don't really learn what is below and what is actually happening below the surface. So they don't, because they don't have the prerequisites to actually understand the models that go into it. But they sort of learn to use the software to analyze things, and this is of course important because it has to be done. But I think there is but this is sort of, to some extent you could say this is not really our problem. I think there has to be a significant increase of mathematics, basic mathematics education in the biology departments as well. And I think this is happening to some extent, but probably not happening as much. Also because biology students are typically don't choose biology because they choose biology because it's not as mathematical, right? It's not, the people with a strong tendency towards mathematics would tend to go into other fields. But I think at some point this has to change. And I think we could be, we could be helping that. I mean, in Cologne, we haven't had the experience. I mean, the biologists haven't been very open to this, so we haven't really managed to have a lot of exchange between the curricula. Also, because the beginning biology students, they have to do lots of labs. The courses are organized, according to completely different schedules. They don't have the courses going through the whole semester the way we have. So this hasn't really worked very well yet, but I think it has to be, this problem has to be solved at some point.
So, it seems that the question how to teach statistical physics to non-physicists is too vague because the ensemble of non-physicists is strongly non-homogeneous and you should perhaps teach in very different ways, and this also clashes with the fact that perhaps you don't have in a given university large enough number of students to organize the courses. So I wonder, and this is a question which I think that is relevant for all of what we have discussed until now, if perhaps non-institutional courses at the university, but summer schools might play some role, where, because a good summer school where you give not 4, 6, 8 hours per teacher, I mean, I think to bedroom, just to have an idea. And with people coming from different countries, might be in some sense not the solution, but a partial solution also for another question. I mean, in these days we have discussed a lot of possible different ways to teach something. I mean, perhaps a summer course might be a way to test something new.
But it's something in the summer course for, let's say, biologists or for physicists.
At master level, you mean?
Not necessarily, but more meaning that
The prerequisites are extremely different, and scholars that basically don't approach biological students.
But in a single summer school, you can organize several different courses which may be very focused, because anyway you can collect people from all around at least Europe.
My opinion is not just a matter to collect an homogeneous sample of people. I think that it's important to put together people coming from different disciplines and expose the same kind of mixed sample to the same kind of teaching and see the reactions. It's clear that some courses will be easily available for the mathematicians or the physicists rather than for the biologists and vice versa. But that is exactly, in my opinion, the difference.
So you saw the summer school as a pedagogical experiment.
Yeah.
No, but the problem is that biological students don't have the mathematical background.
Okay.
You cannot expose them to the kind of things you expose them.
You can make some divided in sort of basic courses where you first cover some cultural gaps and then you join them and see how it works.
But this is, just a few weeks ago,
I think it's
right.
summer schools are good to expose someone to the topic about which he wasn't familiar. So you can go home and learn it. But to teach something in a summer school is teaching, especially in physics, from my experience, as a student or as a teacher, is 95% is to do homework, and you need time to get used to concepts. And summer schools don't allow either of these components seriously. So I don't think that summer school is a replacement for a disciplinary, serious course for these two reasons.
It depends on how we organize the summer school.
Because to get used to concepts takes time, just to sink in, and the summer school is not enough time.
I have a good souvenir of Peru when it took 1 month
I taught in Belgrade renormalization for 2 weeks, and so I gave, I don't know, 10 lectures or what was it, 12 lectures, which normally
I was there.
I normally do.
Renormalization. You were writing a book on renormalization
But you know, so you give 10 courses, 10 lectures, which normally you would give in 10 weeks. And in 10 weeks, the students get used to the concepts and they do homework. And then in 10 days,
they go to sailing.
they say let's play football, which is fine, but it's not the same. It's not, doesn't, I'm all for it, but it doesn't replace a regular course. It's something different.
Yeah, but it is different.
Yeah, so, David, sorry.
No. What I have to say is that, the basic course, the advanced course in statistical physics in our place, is taken usually by physicists and chemistry students. Biologists don't take that course. For biologists, there is a course on, it's called soft condensed matter. So that's less mathematical, more phenomenological. And that's where concepts of statistical physics are introduced in a much softer way. And if biologists take a course, they take that course of soft condensed matter.
I don't think they take that one either.
No, some of them they take, those who are, by now there is enough. So I don't think they are keen on taking, a real course in statistical physics if you come from biology, from the side of biology. It has to be made much more phenomenological, much more soft in mathematical sense.
Right, yeah, because typically the group has already been self-selected by the fact that they don't like to do mathematics.
Do you really think that biologists are scientists who don't like mathematics
That's
as an enrollment?
what's wrong with that? That's the case of the University of Toronto.
No. There is no hope.
No, but the other fact is that we're talking about biology now. Biology is very successful, and unless we can show them a product, they're not going to take the effort to learn statistical physics. And so, I think, in fact, maybe the best solution is what's actually going on. Having physicists actually doing biology, and then convincing the biologists that it's interesting. And maybe after 20 years, something will happen. That's very pessimistic, but nonetheless, maybe realistic.
Unless you're talking about physics students who want to do biology, that's a different story. Sorry?
There are already some schools.
There are, yeah. But to attract biologists to this kind of thing, I don't see that.
But I still think summer schools can play an important role in getting students with different backgrounds to talk to each other and to get to know each other and so on. I was recently in India at the ICPS, and they have a school on population genetics, which they have run now 3 times, and this is open for students from different backgrounds. In practice, in this particular year, most of the students that came had a biology background, but out of 6 lecturers, 2 were physicists, so the mathematical level in different lectures was very different. Now there is of course an issue then with the starting level, right? So I think the issue in such a summer school is always to have a few lectures that actually bring people up to a similar level, and for example, some elementary stochastic processes or something like that, just to give you some flavor of that. But then, of course, if it works well, you can hope that the lectures with different backgrounds will be explained, so the students can explain these lectures to each other, right? So the biologists understand more of the biology, and the physicists understand more of the theory, and that this can sort of work in the way that students actually learn from each other. Right? It's not very certainly, can be a very positive, and I think we all have experienced that summer schools for many of us have been like formative experiences in that way. So I think it's certainly worthwhile.
Many years ago, when I was in the SUSH, homework was made in the school. There were a group of lectures, and then we had the video. It was very big bunch of exercises to solve it, come the day after the solution of the exercises. And as far as I remember, that was a very fruitful experience because students were not obviously obliged not to try to collaborate. And in many cases, that was also a way to exchange information, knowledge, and so on. That was also a very funny aspect because sometimes the exercise has no solution. Playing with the teacher. I remember there was then she gave us a normalization calculation couldn't work at all, so when I was sort of lying creating some moment. But it was, I mean, very, very nice. So maybe I don't see why one shouldn't exactly organize work in school, not just expose work. That was in the ancient time,
But this is physics students.
But this depends if the level of the student is very homogeneous, otherwise.
And we're not very homogeneous at that time.
Okay, it's that can lead toward teaching.
So you see, if I have the experience of collaborating with some genetics or molecular dynamicists for coming from chemistry session, I have the feeling that when I speak with some, not with my colleagues, which at least have a background, scientific background that went on over years of experience, so in some sense fit many of the conceptual gaps that you find in a student. But the students have a feeling, clear feeling, that certain aspects of statistics are just a matter of a collection of recipes. You take the recipe A, you cook that cake, and that's all. Then you have another recipe, the other cake, and that's all. And then if there is any relation between the two things, completely unknown. So it's clear that they live certainly very happy, and even if they don't know there are relations between these things, but certainly they cannot control what they are doing. This is my conviction. It's just to say, okay, I go to the recipe book and I take this, okay. It's like a black box approach. Maybe it's what we're doing, I don't know. I probably am a bit too optimistic or utopistic, and I think that one could make an effort to make also other people understand the basics of things. So, I mean, it's true that teaching through examples is probably the simpler way, independently of starting from hierarchical or for this kind of people, that's sure. But I think that making an effort to extract from the example some basic things is too important. For instance, I would go to a class of biologists, the first thing I would teach them is a random work on a ring. Like a very basic example of a Markov chain. And that gives you the opportunity to explain at least 5, 6 basic concepts. And I think if I'm not facing a class of stupid guys, they will immediately catch them. So it's just a matter, in my opinion, of, how to say, our personal inertia with respect to that. So, I mean, maybe the fact that they perceive the importance of understanding these basic concepts is not immediate. But I think that after a while, that would be the great payoff to these people. It's just, I mean, it's the same thing when I start to understand anything about biology. I'm totally ignorant, and then I would like that someone is going to explain to me certain things because I have no time in my life to teach them. And the hope maybe to have some more, but it's just a limited amount of time. But for a young person, that would be an invaluable fact. Not for me, but for these people, that would be the case. So even a physicist should be, in some sense, exposed to the point of view of our colleagues from other fields. And that's why I would like to put together a community, not just make a specialized stuff. Which is a bit different because, to my knowledge, I don't see that many examples of
But in this regard, on the physics side, I remember when I was a student, chemistry was a mandatory course for physicists. but there was no biology. At least in Italy. Are things changing these days? There is some mandatory biology in,
To physics student?
for physics.
No, not in our
So, I mean, of course, I understand why chemistry was mandatory at the time, but these days people should be at least
You're talking about your bachelor degree?
Yeah. But it was one course.
Chemistry is not mandatory anymore, I think, at least not in general.
I always thought it would be better to.
And it scares our students off. You know, some go to Tübingen where they don't have to do chemistry.
Yeah, so not everywhere. I mean,
Not everywhere, no, not everywhere.
yeah, it was never a problem.
No, but in Italy it was better to offer the try.
I think in our university you have to take some other elective subject, but it could be chemistry, it could be biology, it could be.
So if you can
You can take a genetics course in your bachelor's. But it's not done very frequently, but it's possible.
I'm curious to know from students. Would you be available to pass several weeks during summer to attend courses that perhaps even do exercises on working, or perhaps you would simply prefer I mean, to use the book that your supervisor has passed to you because for your work you need just to know just that stuff.
Okay, I can say two things. I would like to be exposed to subjects, but I totally agree with Professor Domini's view, in that it's very difficult to actually learn something from a summer school. It's better to be just exposed to something maybe you don't know at all, and then you might get interested into it, go home, do some homework, read some books, and be into that. And the other thing I want to say is that I don't really see how it could be helpful to have people with highly mixed background attending the same school. I had the same kind of experience at the ICTS as well. It wasn't mixed in the sense that there were physicists and biology, but there were physicists from StatMech background, engineers, and people into quantum mechanics. And we had several kind of courses, and in the end people would just, like engineers wouldn't show up at some courses. And there were just a few physicists maybe going to all of them, and people wouldn't really talk. And in some cases, depending on, I mean, there were professors like trying to involve everyone, but at the price of not making it interesting for the people who already knew something about it. While others would just like go on with whatever they wanted to do. And of course, there were a lot of people not understanding a word of what they were saying, and they would just leave the class. And that's it. So that's why I think it's really difficult to have
a campus that is well confined, so you kind of leave.
Yeah, that's, I mean, you have to stay there because they leave your bikes though, so you can go around in the countryside, right?
No, but
Maybe, do you have any? I am interested to your.
I haven't been to summer school yet. I'm going to a summer school, a short one, and to me the most important thing was that the subject was interesting and relevant to me, so it's focused only on equilibrium things for physicists. It would be interesting to have something more, go to more interdisciplinary summer schools, but again, I mean, taking 3 weeks out of your summer to go to a summer school to learn about very broad topics, and it's the chance that maybe a lot of it won't be so useful to you. It's difficult trade-off, I think.
Yeah, it's always a bit of a battle.
Yeah.
That's why I'm saying I'd rather go to some place where I can learn something I have not been exposed to before. Like I could go to some, if I'm interested in biology, let's say, I can go to a school made by biologists but for physicists, in which they will explain me basic stuff, maybe make me go to the lab and do some experiments like they do and things like that, rather than going to a standard and hardcore stuff like that.
Another thought I have is maybe online courses could play some kind of role. If I would want to learn something about a topic that I'm not that I haven't studied before, I would maybe do an online course where someone presents it in a pedagogical way, and I can do it at my own pace, and through a couple of months I can get sort of the basics of some subject. So I think with regards to introducing statistical physics concepts to biologists, maybe there could be some role for online courses.
So do you actually have experience with online courses? I mean, have you taken courses of that kind? Or?
Yes, I've taken different kinds of online courses. First it was in machine learning, very simple things. In the beginning of my physics degree, and for a while I was quite interested in that and thought that maybe I would go into computational neuroscience instead of physics, so I took some MOOCs on that and spent quite a lot of time doing that. Now in the end I stayed in physics, not because the online courses weren't good, because they were really good and engaging, but in the end I chose physics.
But don't you think that the level of interaction you have in live courses, I mean, even in summer school it's typically higher since you're in the same place, so then maybe a dinner with the teachers.
Right, but I mean, going to a summer school, it's a big investment, right? You have to go somewhere, you have to find the money, you have to find the time. I mean, online courses are very low investment. You can start it and you can spend a couple of hours and just see, okay, is this something that's interesting and relevant to me? And if not, you just drop it. Or you can put a lot of time in it and you can engage in the discussion forums that are usually part of the online platform. So, I mean, it's yes, low investment. Well, it's whatever level of investment you want.
I think what you say is very true, and particularly now, these courses are becoming much more popular. One of my soon-to-be colleagues has an online quantum mechanics course, and there are 5,000 students registered in this course. It's extremely popular, and I think it might be a generational thing, but I think that now this is actually the way a lot of teaching is going to be done.
Please don't tell my principal, otherwise I'm going to lose my job.
No, you can do one of these.
But I mean, seriously,
Somebody has to make these.
One of the problems is that if you go towards that model, you will need less and less people. I mean, now we have a system where universities are more or less spread on the territory. Now, you can wonder why people should sign up to my courses and not to someone from Harvard, which is more famous.
Okay, but I mean, this is like introducing robotics into manufacturing. I mean, so we have to really live with the times, and I don't know how it will evolve, but this is definitely one of the trends.
Well, what has been told by Henry is strictly related to what we have discussed the first day about the drop in the number of printed copies of books, and one of the reasons proposed by Simon Catering was the different way to read and approach books. And I think that's what we have just talked about online courses with respect to summer courses is exactly on the same line of reasoning.
More seriously, don't you think maybe it's possible to combine these two things? But if the problem is that biology students coming from Urgent don't have some certain kind of mathematical background, can it be possible to offer some online material and then organize a summer school which needs some of this material? And maybe the same for physicists. There are some online material biological subjects for physicists, and then after that people convene at the school for a few weeks. So in a sense we tried before to homogenize. No, I don't know.
I would like to do something like that, for instance, as a student. If there was something like that on a topic I like, I would do it.
I don't know, that's in theory. I don't know if in practice.
The experience I have, the last 4 or 5 years, almost every summer, one of my students attended Begowood. So for maybe 4 or 5 students. Now, if I try to look back and see how it affected their research, I would say very little. In the end, it's a general knowledge and culture and whatever, but the basic courses that they got affected their work much more deeply, I would say. I can ask them explicitly, but that's my point.
Maybe it depends on the nature of the school.
Well, Bekovu, I'm talking about Bekovu.
Okay.
But their sailing skills haven't.
Yeah, that's it.
I should say the same with my students.
So when I was a student, which was not very recently, I attended a summer school for 6 weeks on quantum mechanics, and in the winter in Florida, which was very nice. And that had a profound influence actually on my research, because these were concentrated lectures for 6 weeks by some of the best people in the field.
On some basic topic.
On basic topics, absolutely.
Right. General
Yes. Basic topics, yeah.
But it was 6 weeks.
Right.
Pardon?
But it was 6 weeks.
Yeah.
If you would have had something maybe along the same lines, but like shorter, like most of them now, for instance, 2 weeks or something like that, or maybe 2 weeks, but with 15 lectures,
Yeah.
then it wouldn't have been as helpful as it has been, right?
Yeah, probably. It probably could have been okay for a few weeks, yeah. The second 3 weeks were on
the
the
format of a possible summer school is.
I think courses should teach, in a course you should teach general stuff. I mean, when you go to do your own research, you have to you read books, you have to read papers, you have to, you have to get down, to it on your own. So courses should be cover more general principles, more methods, more, not really pick a different, very specific topic and get into it. Usually in research you do it yourself, right? I mean, you learn.
Knowing some general principles in advance helps you to understand papers. If you have a framework in which
Yeah, but you need a framework. You need the general, to be able to penetrate these papers, and you need the general, concepts.
I do agree that, but this
You agree?
I do agree with what you're saying, but I think that you must have access with the good instruments to understand the basic topics. If you have not the instruments, that's a problem. That's a major problem, because part of some kind of, so maybe it's a false problem because we don't care to teach these kind of things. But if I'm going then to discuss with a biologist on the relevance of some statistical inference that you can dig out from some bunch of data, our point of view is generally completely opposite. I don't find any way to make even the young guy understand what I'm speaking about. They don't understand what he's speaking about. That's a problem. Maybe it's an impossible problem to be solved because the barrier is too high, but that's the point. It's another point which is quite important. And if we want really to exploit the interdisciplinary character of this domain, I think that we should be concerned. It's not obvious at all how to get out of this problem. If it is a problem. I don't know. For instance, we had experience that, okay, you teach basic things, but try to organize and bridge concepts coming from dynamical systems, statistical cases, kinetic theory, and so on. We got a great advantage of having a computational laboratory, but people were exposed to know how to translate that in a computational language. It's not just a matter of a bioinformatics who knows how to write the flow of the program. It's just how to translate in a specific language, which is the one of numerics and simulations, some basic concepts. Because if you have no knowledge of the basic concepts, what you are cooking up is nonsense, full nonsense. This is, in my opinion, the main important fact that comes out from this kind of experience for the students. And naturally, we decided to make it before the basic courses, in such a way that they were exposed to know which are the programs they are going to meet. Typical example of my students that remain quite astonished when I explain to them why the algorithm works, because it is symplectic, while the non-relay algorithm doesn't work, it doesn't conserve energy in any internal system. So this is something that everybody understands.
Let me understand if they know what means symplectic.
No, you explain to them that it is not.
Often the students symplectic is strange name.
I have to explain to them. If they know Liouville theorem, you explain that Liouville theorem is a consequence of that. But I mean, but the computational aspects not made afterwards, but made before, helped a lot. And even translating, for instance, the use of in a simulation of a random number generator is quite a crucial problem. It's a problem not only for physicists.
This is sort of something I said that already on the first day, that my feeling is that exploiting the easy availability of simulations in courses on statistical mechanics is something that one, could be improved greatly. I think it's of course, I think it doesn't necessarily replace the mathematical understanding, but I think it can help the students understand things greatly if they can simply write a code themselves and see how the reversibility emerges as you go from 3 particles to 5 and to 6. Right? I mean, this is I think always surprising that n doesn't have to be that large in order to see really macroscopic behavior. So I think this is something that I'm very bad at this. I'm not used to integrating simulations in my courses in an easy way. But I think it's something that needs to be done, and that would alleviate a lot of pedagogical problems as well. I don't know what the experience of other people is, but I think this is certainly.
I think you're right. It's not exploited enough. We occasionally give courses on molecular simulation, but to actually put them into practice, it's really the people who ultimately start doing research in the field that develop the expertise in this area.
But we have in the bachelor's program, as you said, we have a fairly early course. I think it's in the 3rd semester. In any case, before they learn statistical physics, they have a course in computational physics. So they should all have acquired knowledge in a programming language and be able to write their own code. And I think this, especially, of course, it's useful for other theory courses as well, but particularly in statistical physics, I think it's something that we can really make a lot of use of.
Yes, because it's not just a matter of technicality. This is what I want to point out. It's not just a matter of the technical point to write down an algorithm. It's that in writing correctly an algorithm, using correctly these tools, has strong, basic, conceptual implications. That's the important thing to be taught to the students about. I gave it for them as an example. If you misuse a random number generator, you can obtain anything you want from a system that is predicted to mean other things.
Well, this famous example in the early 70s with the IBM random number generator. All of the random numbers were on a plane, and there are many, many papers in the literature that had to be just discarded because of that. I was going to say that, having taught statistical mechanics for many years, particularly if you consider equilibrium statistical mechanics, and there are tens of years of development of integral equation methods for simple fluids, and various closure relations. They work some for hard spheres, some for liquids. And my own opinion is that, now you can do that in a few minutes on a computer and get the numerically exact answer for all of these problems, and you wonder why are you actually even thinking about presenting this? There are changes, but that's only my point of view.
At least my physics students in physics, when I try to explain to them when we try to reconstruct the trajectory of a Newtonian system in general, we're not actually doing that. That's a shock to them. Why does it work? I mean, it's very, very deep for certain implications. I don't know if this is the usual approach in these questions, because apparently everything seems to work, but actually, the fact it works is not at all obvious.
I have a question for Stefano. For you, I have a special question for you. Because if I remember that CISA has devoting attention to teaching. So, I mean, is there any experience about what we are discussing?
I arrived too late, so I don't know what you were discussing.
No, in general.
So, but if I have to say something very peculiar of CISA, is that we have this first year of PhD, which is essentially courses. So, and indeed, with exams, but that's because our PhD extends over 4 years. So that's not the Italian standard. Of course, it's also go to the US or to Israel, there is not even a duration of PhD, but all PhDs in Italy cover, at least the fellowships, cover 3 years. So we are very accurate in this choice of topics in these lecture courses. We try to be general, but of course I cannot say that we succeed. Some of our researchers likes more to talk about his own interests, but one thing that we decided recently was to host PhD students from everywhere. So we have a program that we can. So after we visit to our lecture courses, you can find them on the web. We have a program that is devised to host students for short periods if they find an interest in a specific lecture course. So that you can read on the web on the content of the course, on the timetable, and they might decide to stay at CISA for a month, a couple of months, and listen to the course and interact with the CISA researchers. This is a recent thing that we did. Usually the students, which are around 60 every year, that we enroll, choose their topic at the end of the first year. So they follow these lecture courses and then they choose the topic.
So the first year is especially devoted to
just teaching. So for instance, a PhD in statistical physics, you can. So I understand that this is an uncommon choice, because you would expect that you come into a PhD school and you start already a research activity. No, but this is I mean, it's uncommon.
In Rome, the first year,
only teaching.
So we have past assessments.
So we don't do it in Florence, that's why.
Or I don't think because in engineering the student starting immediately with the research.
Engineering, biology, yeah, and maybe you were referring to something else. I don't know about. Yeah, this is one feature that apparently was involved. They're following the same style. And interesting new program is the one of open. Also, if people from Rome want to come to stay a month at CISA, we have devoted a special funding. So we attribute a very important, strong importance to lecturing. And this, I think, has an effect, gives a very strong autonomy to the students. So indeed, the general comment that I have on the quality of the students at CISA is that they are very independent, autonomous. They tend to also develop their own activities. So that's also because it's a huge PhD school, 280 students. So they form a community in some sense. So it's a small place, it's a small campus.
How many different fields?
In the different fields?
No, the mathematics.
3 physics, 2 mathematics, 1 neurobiology. One mineral science. So that's the ratio, more or less. For 3 physicists, there are 2 mathematicians and 1 mineral scientist.
They are much more introductory to the topics we're discussing here, but essentially that's exactly.
Do you have any sense of how much that is being used?
I think they're quite I don't know whether they do some figures of how many attendants are participating or taking advantage of that, but it seems to be quite a large number of people, at least to be working on. But that's true. This is a new instrument which is quite casual that today might be ruled them because new generations certainly have a much more aptitude to go and attend something online and probably is much more effective, which is okay. I mean, good fact. But on the other hand, I think that in order to train people also to make research in a proper way in some interdisciplinary field, physics. The idea of exposing together people from different areas would be probably useful. Despite the standard method is to concentrate on the very specialistic topics, which I don't know if it's really the right thing to do. This might be. There's no widespread consensus on that. Certainly, in the future, we could plan to improve these online courses in France and also make something more specialized or high level. But I don't know if this is the only possible answer to these questions. I'm pretty sure that maybe some pieces will attend, but then you can check after how it works.
I think one advantage of the online course is that in any one location, the population might be very sparse that would take such a course, but capture people worldwide, and so you might be able to get a good audience for what you might think would be a rather restricted subject.
But in Scotland, we have this system where SUPA, which is an alliance of physics university, has common courses, and they are delivered online, I mean in real time. Then of course lectures are recorded and students it's a different beast with interactive data.
Yeah.
Much less satisfactory, I should say.
We tried this quite a bit, I mentioned this joint graduate school that we have at the University of Bonn, and so there, at least initially, we tried quite a bit to broadcast lectures to the other places. I mean, these two places are like, 30 kilometers apart, so in principle you could commute, but of course it's also easy to be able to stay in your own place. But I think in the end, this turned out not to work very well. So the attendance, I think I taught a course like that once or twice, and then you would have a screen with the one students. But attendance was very poor. After a while, the screen would be empty. I would just see the empty chairs there. So I think it's, in the end, I think now the students actually are commuting more. So I think most of them find that it's more, even if it takes more time, it's sort of more, more rewarding to actually go to the other place. So I think it's not that easy to really make that work. Although in principle, of course, you can do it. You can ask questions. You can get responses. But I found the technology, maybe the technology wasn't good enough. There was a problem of setting it up and then it wouldn't work and so on. So it's,
I think the technology is changing a lot.
Well, I admit that we are activating this kind of things only if not enough lot of students to give a sense of interaction. So there will use 4 or 5 people and in front of you it's easier than that.
I think that we speak about online courses, but perhaps we mean different things.
No.
There are real online courses, for example, as given by the Santa Fe Institute, which are thought from the very beginning to be attended by people everywhere and who are not physically there. So this also means that, also from a technical point of view, that they are organized different.
Sure.
Then, of course, each of us who is teaching, as now, you can simply record and broadcast either on air or in a second moment. This is much easier, of course. It is much easier, and there are a lot of them on YouTube.
But I don't know if in general. I was speaking with some colleagues from economics in Aberdeen, and they are preparing a series of online courses, an entire online curriculum, but they were complaining that the level was going to be kept lower than normal courses. But I haven't understood if it's a choice to attract a wider audience, if it's a limitation of the media, that they were complaining about the level. It's too diluted and simplified.
Okay, we think that perhaps we must close this final session, and that also we close this workshop, and we hope that, at least for the novelty, you have found it of some utility. Of course, we have recorded almost everything, so we plan to split what we have recorded in different files, each one for each lecture, and perhaps we will also ask you the slides if you are able to make them public on the web. Perhaps one of the next days or week with Roberto we will meet to try to summarize something, and we'll send you our, I don't say conclusion, our final consideration. And at this moment, I don't know if there will be some follow-up.
Well, we hope at least to have some comments for you. While having some comments, maybe we don't miss something, or if it comes to your mind some new consideration about that.
Okay, so thank you very much.